Alright, this is a video for the Lab 6, the project parts. So for Lab 6, we have three simple parts to make, and as you can see here, those are the knob and the locking block, which is inside the handle, and the lastly is your stopping block, which acts as a wedge. Excuse me. So for the knob and the locking block here, those two, we don't require the teeth, those parts and the sharp teeth here. Okay, and also we get rid of the pin with spring inside the knob. You don't need to do that. Okay, so what you need to do is first you want to download all three of the mechanical drawings, the draftings. So they will be looking like this. Okay, you should have enough dimensions to create those three parts. So here I'll try to make this video for the first part. Okay, maybe the second and the third. We'll see. Alright, let's start. So if you have a look at those three parts inside the locking pliers, they are about those locations. And first let's start with the knob. Okay, and alright, let's have a look at the drawing. Okay, so here's except the tolerance, we don't put tolerance in this drawing. But usually, if you look at the manufacturing the drawings for manufacturing, you would see tolerance, reference, the datums, etc. But I guess we don't have time to cover those. So here is pretty much look like a mechanical drawing for manufacture. So as we can see, we have for this particular part, okay, we have several cylinders in the middle, and basically this is a symmetric part except the pin in the middle. The smallest cylinder, you have asymmetric height. Okay, so once you get this drawing, you want to start modeling, then um, this will give you a feeling like if you got some drawings from a factory, how do you turn them into digital files? So first, let's see. Basically, we got like one extrude for the smallest cylinder in the center, and the second extrude for this 9/32 dimension diameter. Then the last would be like this shape, also with different depths. So you can either extrude this part with a circle first, then extrude this the right part with a thicker distance, or you can extrude the whole piece here to 3/8, then cut into this piece to create the geometry. So now we have a general idea of the process, how we should make this. We can start the file. As you can see here, one extrude, two extrude, and three extrude, the fourth. That's what I did. And in this video, I'm going to show you extrude the whole thing first, then cut back in to the required thickness. So let's turn this off. Also turn this off. New file. I would like to save to some place I have access. Okay, and don't forget to rename your part. And let's have a look. So let's start from the simplest thing. That's the 530 seconds cylinder. So you can start a sketch. Since this is a very regular feature, we can just come here, insert, design feature, and cylinder. Okay, and the specify vector, that's the extrude direction, so that'll be Z. Specify the point, it's automatically gave you the origin. So diameter, let's have a look. 5/32, and height. Alright, this method, the problem with this method is it's hard to do a symmetric, but since the cylinder is not symmetric, okay, that's fine. So 5/32, the height is, look at here, okay, 5/32 plus 3/16, 5/32, 3/16, and if I apply now, okay, vector, show results. Oh, that's why it's pretty small. The problem is, okay, as you can see, the bottom is right on XY plane. So I would like this to put XY plane in the middle. So I need to move the cylinder down, which is 5/32. So let's go back to NX. I need this vector, this point. So I'm gonna open the point dialog box. Change the Z coordinate to -5/32. Okay, and show results. Okay, click OK. So I did 2 cylinder. It's like you insert a node. Okay, every time you click apply, you will get another one. So I'm going to delete the first one. That will be the one we want. Then we can start to make this cylinder. That's 9/32. Okay, and I'm gonna do this a traditional way. So sketch, XY plane, circle, 9/32. Okay, finish sketch, extrude. So here we can control this as symmetric, which is 1/4 inch in total. So that'll be 1/8. And yes, we can unite with the first cylinder. And if you want to look at the depth, just hit enter. So that will give you some preview. Okay, and if you look at the drawing, you can see we have a transfer here, which is 1/64. So we can put a transfer, and for the bottom also 1/64, and it's a symmetric transfer. Alright, and then move to the headache part, where all the dimensions come from. Okay, so basically we're going to draw something like this, and as the slides indicated, the teeth are not required. So if you want to make it, the dimensions are there. Okay, in this video I'm not gonna show that. So let's start draw this part. The biggest circle here is 5/32 in radius. So sketch on XY plane, and we can hide everything, or just hide sketch and extrude. Okay. So a circle with a radius of 5/32 will be 5/16 in radius, in diameter. Okay, seems like I didn't put the dimensions in. Okay, then next we have two tangent line which is 29 some degrees to each other, and let's see. Okay, 29.265. Okay, what we do is we can draw two lines first. Okay, and you can make this symmetric, then we can just put angle here, which is 29.265 divided by 2. That will be half of the angle. Then for this, I'll put this equals to P9. Okay, and go back. Now we can make those lines. So this arc here, zoom in, looks like a fillet. So I'm gonna make this a big arc, which we have a intersection point 3/32 inches from away from the origin. So we can draw two lines on x-axis, or just randomly draw something like this. Okay, then we can quick trim. Then we get an intersection point. We can put this using the point on curve constraint. Put this point on x-axis. Alright, then we can give this point a dimension from the origin, which will be this 3/32. Okay, then we will define the angle, which is 102.764. So here is 102.764. And again, we want to make sure this is symmetric. So I'm going to put another one to make sure this one is symmetric. So P12 divided by 2. Okay. And then keep going. That's the next two straight lines. Top and bottom here will be 47.321 degrees. And let's have a look. How do we find this intersection point? Its own, and circle is what is the diameter of the radius? Look at this arrow here, 5/16. So what we do is we can draw a circle, or you can, if you don't like the whole circle, you can use 3-point arc. I'm just gonna use the whole circle. So the radius is 5/16. Diameter is 5/8. And close this. Turn this to reference. Let's have a look. Where's the? Okay, this is not vertical. No, that's our dimension. All right, two straight lines, and we want to enable the intersection snapping tool. Here, one line, and another line for the bottom. All right, so here we can add two angle dimensions, 47.321. Alright, so what we can do is like hit this 47.321. Okay, and don't forget divide by 2, since we're marking this line to x-axis. Now for the next line, simply type in P15, which I have here. Might be different on your model. Alright, so at this point, it's pretty much almost all we need is the arc, which represents the teeth. So have a look. 3/8 in radius, that's the top of your teeth. So 3/8. So now we can use a 3-point arc. Guess we should define the center first, then start point, end point. Okay, and we can give this a radius of 3/8. Alright, so we have the lines, we just need to clean this up. So trim off all the lines you don't need. Okay, if you look closely, that will be the geometry. And notice the sharp corner here, we need 2 fillets, which has the radius of 1/16. So this, also this. Finish sketch, and compared to what we have here, that's pretty much the geometry. So the extrude will be 3/8 extrude. Okay. Also, we want symmetric. Since this is a symmetric part, you always want to make the model symmetric on your datum plane. So 3/8 would be 3/16 in half, and I don't want to unite now because I'm gonna still need to cut this off a little bit on the top and the bottom. So we can have a look here. You cannot really see what's inside. Let's keep doing this. Just cut this off the top and the bottom. Cut this, cut that. Okay. So what we need is this arc. 3/16. If you look at this arrow. Okay. So this cuts into this 3/8 depth. And let's see where this goes. So the thickness of the lowest point here is 3/16, and that's 3/8. So we have 3/32 on the top. Okay, or we can think about that later. So all we need is this arc with something bigger than whatever inside here to cut the solid we have. So that's 3/16. Okay. So what we do, another sketch maybe. Okay. Of course, you can just draw a sketch within one extrude, but that's hard to manage for me, so it's personal preference. Alright, the radius is 3/8. Okay, and actually that's enough. See, we have the arc which goes outside the solid, and all we need is cut this portion. Okay, so finish. We will need to extrude. So for the first one, as you can see in the drawing, it's 3/16 on top of in total thickness. So a half will be from the XY plane to the top surface will be 3/32. Okay. Then we will start from 3/32 to maybe 1 inch. Okay. So we will cut off this. We can use subtract, apply, So that's what we want, and we can do the same for the other side. So we can put a minus here, another minus here. Done. And let's look at this. Okay, so that's almost done, but we have some fillets here. Okay, if you that's a big chamfer, 3/64. Okay, so chamfer 3/64. Pick this edge, pick the bottom edge, apply. All right, and actually that's good enough for the project or for the report. If you look closely, we do have another chamfer small here, and we don't have the dimension for that. The reason is this is not that important. So for those, we can simply pick them up, off all of them. Okay, then you can adjust the distance. Don't even need to look at the dimensions. So that looks good, which is 0.01. So if you want to use this one, feel free to. Then click OK. Okay, then let's hide the sketches and have a look. So that's the modeling process for this knob. Okay, we can move to the second part, which is the locking block. This one.